Welcome to Act on Energy, Acteon's podcast where offshore expertise and innovation meets global energy insight. Hosted by a range of voices from across our global teams, we dive into the data, engineering knowledge, and operational expertise, driving smarter, safer, and more sustainable energy solutions. We act across the full project lifecycle, and we're here to unpack the ideas shaping the future of offshore energy. Let's get started.
Hello everyone, I'm with Acteon. I work as a marketing campaign lead and my name is Guste Cesnuleviciute. I am here today with Justin Carpenter. Justin, welcome. Introduce yourself to everyone.
Yeah, I'm glad to be here. You know, I came all the way across the Atlantic just for this.
Just for me. I feel extremely delighted. Thank you.
Yeah, I'm with Acteon's Geo-services business line, and I'm the sales and business development director.
Brilliant. Very nice to see you today, Justin.
Yeah.
We're here today to talk about your career, basically, in geotechnical and sort of that technological evolution that you've seen, I guess, across your career. Prepared some questions for you, so let's dive in, right?
Sure.
So what would you say was the first thing that sparked your interest, really, in the geotechnical engineering, especially in sort of offshore marine environment?
This started many years ago, and I would say in high school, in my 10th year of school, where we had various engineers come and discuss potential careers in mechanical engineering, civil engineering. And I still, at that point, didn't make up my mind which field of engineering I wanted to be in, but I knew I wanted to be an engineer. So flash forward a couple years later, didn't really get to pick the school I wanted to go to. I'm 6'7", by the way, so I went to play basketball.
Of course, yeah.
And when I was an undergrad, I did engineering physics degree for a couple years with the ambition of doing a master's in some specific field of engineering. Let's just say I'm a better engineer than I am a basketball player. So I quickly decided I need to move on from basketball and go to engineering. So I applied to a number of different schools and I was accepted into environmental engineering. So it's another branch of civil engineering, but not quite geotechnical. And I promise I'll get there. So in undergrad, I was sort of following the money, following the scholarships. And so my next scholarship was the transportation scholarship. So I went to transportation engineering.
Wow. Okay.
And funny enough, my least favorite subject in undergrad was geotechnical engineering. So needless to say, right after undergrad, I went into professional working field in a non-geotechnical engineering role. But it gave me a year just to think about what I really wanted to do. And I knew I wanted to go back to grad school, and I started looking at the market. I looked in geological engineering, geotechnical engineering, and just various applications. And the more I delved into geotechnical engineering, I saw some very unique applications in deep water environments that I just wasn't really exposed to. And I said, I want to do that. More importantly, I get to travel the world.
Yeah.
And so it's a no-brainer, and it's been no looking back since.
Wow, brilliant. Now it's interesting, right? And as you said, you've sort of taken that year off a little bit to sort of get yourself right and understand exactly what you wanted to do. And here you are now, right? As sort of
if I could rewind time, I wouldn't choose this path, at least how I got here, but I don't regret it whatsoever.
Yeah. Oh, that's brilliant. So would you say, was there like a defining moment or project that made you realize that this was the right path for you, really?
Yeah. So I would say it's one of the first times I worked offshore. So I did join the company originally back in 2012, worked for a year before going to a major oil and gas operator. But during that year, they really empowered me. So I started off as a very low-level junior engineer. But over the course of the year, I worked my way up to a shift engineer, then just the lead engineer for offshore operations. And it's just the empowerment by leadership and making those decisions independently, which I guess put me here today and just gave me that confidence to get to where I am now.
That's brilliant. They always say it's a good manager, right? It's the people that empower you around you. That have such a big impact in where you go next, right?
No, absolutely.
So obviously, you've been in this career, you've been doing this for how many years now?
Oh, let's not put my age out. Geotechnical, I would say about 15 years now.
15 years. So obviously 15 years to some might not sound like a long time, to some might be the other way around.
Right.
But how would you say that the seabed drilling landscape has changed over the past 15 years that you've seen it?
That's a good question, because it really, to be honest with you, it hasn't changed greatly in 20 plus years. But if you look at sort of the beginnings, it starts off with these seabed CPT units that were first brought to the market maybe 60 years ago or so. Then you have the likes of the prod system, which came to the market about 25 years ago, and we were sort of the forefront of the market. And then over that 10 to 15 years, there were some other players, but they never really gained traction. Right now, currently, it's a very exciting time. There's a number of seabed drills coming to the market, and they all have their different attributes. But in my eyes, they're all fundamentally based off of this infrastructure, that seabed CPT going back 60 years. And then some of the features you see now are somewhat prod-like. And so what they say, imitation is the biggest, what is it, of flattery? I forgot.
Yeah, it is the flattery. Yeah, imitation is the biggest flattery. Yeah.
Yeah, and so even though we have people chasing us, but they're using some of the features of our drill, I don't mind.
Yeah, of
Because
course.
it tells us that we're doing things
Something right.
right. And we've completed close to 90 site investigations. And that's very impressive in this market for the type of tool that we're offering.
Absolutely. Yeah. How would you say the transition from oil and gas impact site investigation requirements?
That's revolutionized the industry, because when I first came to the market, we were just talking about small greenfield areas, maybe for a fixed platform, for a floating platform, but just really relatively small area. Now we're talking about wind farms that cover massive areas. And so you're generally still doing the same types of operations. You're doing your CPTs, your sampling, rotary coring, but you have to do it at dozens, sometimes hundreds of sites to better characterize the area. But in addition to that, we're seeing a big push for various in situ measurements outside of CPT, so seismic CPT, PS logging, and other downhole geophysical measurements. And so it's come quite a way. I mean, geotechnical, at least the offshore drilling component, techniques have improved over the past, let's say, 60, 70 years, but fundamentally, we're still doing the same thing. As my engineering manager says, he says, we're here to collect data and dirt.
I love that. I love that. I will be using that now moving forward. Okay, so would you say that sort of the biggest challenges in seabed drilling also are quite similar, like compared to sort of back in the day as well? Or are you sort of seeing some sort of a shift and some new things sort of popping up?
Yeah, so as we make that energy transition from oil and gas to fixed wind, we're seeing more shallow water projects, which seabed drilling, there's some very keen advantages. And I mentioned them just a second ago. I mean, one is the weather operability. More conventional technology when they're operating over the winter, since they're drilling towers connected to the vessel, and although there's heave compensation, they are greatly impacted by weather, especially when you work in environments like the North Sea. More recently, a few years back, but we were operating in the middle of the winter in the North Sea and also the Baltic Sea. And I think those projects, we incurred about maybe 15, 20% weather downtime, which is quite impressive. And we've heard other horror stories of other competition with more conventional technology being down on weather, 50% or more. So
I mean, that's quite a comparison, isn't it? Wow.
No, absolutely. And the other thing just relates back to the sample quality. Since we deploy our systems remotely operated, lands on the seafloor, once the vessel starts moving around, we're not impacted whatsoever. And as long as we can deploy, let's say in seas upwards to 3 meters HS and we're on the seabed, there's no energy imparted to our system, nor on the samples or the data collected on the seafloor. And so those are things that we don't mention enough, but we try to highlight to the client, because in the end, we're here to deliver that data in dirt, but also to sort of de-risk their project.
Brilliant. It's brilliant. What's a lesson that you've learned from a difficult project that you still carry with you today? Something that has stuck with you to this day?
There's been plenty, of course, and none were technical challenges per se. It's all about HSC. And as a young engineer, you never want to stop the job. So there was times where I should have stopped the job, but you're just so driven to get things done. But in the end, it's about safety. But we were offloading samples, so we were on a big geotechnical drill ship, and there was a smaller boat that pulled up. The bow pulled back to the vessel, and we were just handing over core boxes. So these core boxes were probably at least 30, 40 kilos, and we were just handing them over. And mind you, the seas were not flat calm. So the bow of this vessel was rocking up and down, probably a meter at a time. And there's this young man trying to basically catch these core boxes that we're handing over. Our vessel's very stable, but there was a time where the wave hit just right, and I swore he was about to fall off, and he sort of leaned in towards the boat where he easily could have fell in between both vessels and been crushed.
Oh my goodness.
Luckily, we had someone that did have the courage to step in and stop the job, and that was the captain, where he called off operations. I mean, it was sort of in the same time frame, but I regret not at that point saying anything, and I waited for someone else to say it.
Listen, but you've learned something from it, right? It's just the thing that you think about it to this day.
Right.
And I'm sure you never made that mistake again.
No,
it's now
absolutely not.
safety above everything else.
Right. And it's a good story to young engineers.
Exactly. To wrap up, I've got an exciting question that I'm sure no one will see it coming, but what advice would you give to young engineers or professionals who are considering entering this field today?
Number of steps. First, I would say is just seek a mentor. That was invaluable to me as a young student, even going through college, but even more important as a young engineer. Second of all, get an internship. That was also valuable. None of my internships were in geotechnical engineering, and that's probably the reason it took me so long to get into offshore geotechnical engineering, because I didn't have that exposure. I did some pretty interesting internships. One was with the USDA and RCS back in the States, so United States Department of Agricultural Natural Resources Conservation Services.
Oh, wow, that's quite a mouthful, isn't it?
Yeah, so my background is my grandpa was a farmer, and so what they have an engineering division, and what they're doing is a lot of surveying of earthen structures. It could be dams, ponds, retaining structures, but for farm applications. And so that's sort of where I knew I was the dirt sniffer. That's the derogatory term for the geotechnical engineers. But I think that's really when I became interested in the soil itself. But that was, once again, invaluable to me. Yeah, so I guess the last point was just regarding just the practical experience. What we see now are students sort of in a rush to, I guess, go more on the consulting side, but without that fundamental understanding of the soil and the data and how it's collected. And so that comes through working offshore. So I would highly recommend working offshore. Your first few years, But who am I to say about that? Because I only worked about 2-3 years offshore. So to each his own. But I think if you're going to be the best engineer, the best practitioner, that's the best way. But then you talk about my transition, because I'm no longer an engineer. I still use those insights, but I've moved on to sales and business development. And how that happened, I saw a lot of engineers that were very passionate about the dirt.
It's all about the dirt.
It could only take me so far. And don't get me wrong, I'm very passionate about the field itself. But one of the things I saw was there was a gap when trying to sell to the clients. You definitely don't want someone that's overly technical, but you want someone that has that background and that can relate to the client. And I'm just trying to address some of their challenges, but with that background in geotechnical engineering, I think I'm best fit to address those challenges.
That's brilliant. Brilliant story. No, thank you so much for joining me today, Justin. And yeah, I'm sure we'll do this again sometime.
I look forward to it.
Yeah. Okay, thank you.
Thanks for listening to Acteon Energy podcast. To learn more about how we're applying our data, engineering and operational expertise from seabed to surface, visit acteon.com. Don't forget to follow, rate and share. Until next time.